A very good day to our lecturer, Professor Madya Dr. Saiful Azhar bin Ahmad Tajuddin, and to everyone watching this video. We are from Section 4, Group 3. Today, our student engineering consultancy firm, Sepakat Konsultan Engineering Sendirian Berhad, is proud to present our engineering proposal for 6-story hotel at Lot 27139, Jalan Persiaran S2/B2 Seremban 2, Negeri Sembilan. Let's meet the team behind this analysis. This is our team member for Sepakat Konsultan Engineering Sendirian Berhad, which is Safwan bin Muhammad Shukri, Nur Syazrina binti Samsudin, Muhammad Saleh bin Sobri, Muammar Razin bin Mazlan, and Muhammad Aizul Hakimi bin Razi. This is our team member for representing Sepakat Konsultan Engineering Sendirian Berhad based in Johor Bahru. Our vision is to stand as a world-class engineering firm recognized for innovation, safety, and sustainable infrastructure. To make this vision a reality, we anchor our project execution on 4 core missions. First, we deliver safe, efficient, and industry-standard engineering services. Second, we focus on meeting client expectations through exceptional quality and absolute reliability. Third, we actively adopt the latest technologies and continuously upskill our team. And finally, we build long-term trust with our client and partners through high integrity. This development focuses on the engineering design of the 6-story structure located at Lot 27139, which is at the Seremban 2. We are operating under the direct appointment of our client, which is Seri Maju Property Holding Sendirian Berhad, and are collaborating closely with the architect Nusa Design Sendirian Berhad to ensure the structural scope aligns perfectly with the architectural blueprint. Sepakat Konsultan Engineering is proud to act as both the civil and structural consultant and the geotechnical consultant. This dual responsibility allows our team to bridge the gap between soil mechanic and superstructure load distribution flawlessly. Furthermore, the mechanical and electrical framework are being engineered by Integrated MAE Solution Sendirian Berhad. To conclude our project overview, this development holds a total estimated cost of 10 million with a strict, highly organized timeline of 24 months.
Next, I will explain the soil profile and investigation carried out at the project site. A total of 5 borehole BH1 to BH5 we drilled to identify the subsurface soil condition and determine a suitable foundation system. The investigation found that the upper soil layer consists mainly of slightly sandy slate, and high plasticity clay. These layers are generally weak to medium in strength. A competent bearing layer was identified at the depth of approximately 21 to 24 meter, making dam foundation the most suitable option for the project. This slide shows the column load and foundation layout. The 6-story hotel is supported by pipe foundation system, with structural load and transfer from the column to the pie cap and then to the pie. There are 25 columns which load ranging from about 755 kN to 5714 kN. To simplify the foundation design, this column will divide into the 4 load groups, labeling P1 to P4. This slide summarizes the bore result. The borehole show that the site consists of topsoil followed by slimy sand, sandy slide, high plasticity clay, and finally dense to very dense sand or gravelly sand at greater depth. Some borehole record low SPT and value in the upper layer, indicating wet and compressible soil. However, the SPT and value increased to 50 at deeper depth, confirming the presence of a strong bearing layer. The competent bearing layer was encountered between 25 and 24 meters, which support the selection of pile foundation for the project.
On this slide, I will explain the design methodology used for our pile foundation. We selected the Meyerhof method for sand because the site investigation showed that The pie will be founded in dense granular soil. This method calculates the ultimate axial load capacity of the pie by considering two main resistance components. The first is the end-bearing resistance Qp, which is developed at the pie tip, and the second is the shaft friction resistance Qs, which acts along the embedded length of the pie. The total ultimate pie capacity is obtained by adding these two values, where Qu equals Qp plus Qs. In addition, the design follows Eurocode 7 to ensure the foundation satisfies post safety and serviceability requirements. Next, I will explain how the ultimate end-bearing resistance or Qp is calculated. The equation shows that Qp depends on the pie base area, the effective overburden pressure at the pile tip, and the bearing capacity factor and Q star. However, the calculated value cannot exceed the limiting end bearing pressure, which is determined using the second equation. This limiting value depends on the atmospheric pressure, the bearing capacity factor, and the soil friction angle. This parameter helps ensure that the pile toe is not overstressed and that the foundation design remains safe and reliable. Next, I will explain about the general bearing capacity equation. This equation used to evaluate the ultimate bearing capacity of the soil. The equation consists of three components, which represent the contribution of soil cohesion, effective overburden pressure, and the unit weight of the soil. It also includes shape factors, depth factors, and inclination factors to account for the actual foundation geometry and loading condition. By combining all these parameters, the equation provides a more realistic estimation of the soil bearing capacity, helping engineers design a foundation that is both safe and economical.
Next, I will present the foundation engineering calculation for the proposed six-story hotel. The purpose of this calculation is to design a safe and efficient pile foundation based on the column load and soil investigation result. The design purpose include pile station, pile capacity analysis, and pile cap design and the settlement verification. This slide shows the pile design calculation. The selected column has factor load of 1293.7 kN. By divide it by the load factor of 1.4, the service load is 924.07 kN. The required number of pi is then calculated, although the result is less than 1 pi. 2 pi are adapted to provide suffered load capacity and improve lateral stability. 400 mm times 400 mm precast concrete pile with a length of 28 is selected. The pile capacity is calculated using the Mayhoff method, considering both base resistance and kind friction under the unfavorable design condition. Finally, the design is verified by checking the pile capacity and settlement. The governing pile capacity is 1824.47 kN, which is greater than the required load of 646.85 kN. This confirms that the pile has adequate capacity to support the structure. The design cap has a dimension of 1.25 meter by 0.8 meters. The settlement analysis using the Paulos and Davis method gives the total settlement of 1.81 mm, which is well below the allowable limit of 25 mm. Therefore, the proposed pile foundation design is safe and satisfactory. My name is Safwan Mehwan Shukri. So now I will continue the presentation. This slide shows the existing soil condition and the need for soil improvement. The site consists of weak, slaty sand and high plasticity clay with the SPT no recover zone and high groundwater table of 0.61 to 1.76 meters, since the hotel will carry the maximum load of 5,000 kN. Soil improvement is necessary to prevent excavation, settlement and ensure foundation stability. The recommended soil improvement is a method excavate and replacement, stone column, deterring water system and temporary shoring. After the improvement work, SPT and plate load test should be conducted to verify that soil meet the required bearing capacity and settlement requirement. This slide explain why we need selected a pipe foundation. Shallow foundation are unsuitable because of the wet upper soil. The disc bearing layer with the SPT and value of 50 is located at around 28 meter. So RC square pipe or HSCP pipe are recommended to transfer load safely and reduce settlement. In conclusion, due to the wet soil and high groundwater level, soil improvement and pipe foundation system are recommended. This solution provide indicate bearing capacity, minimize settlement and ensure the long-term safety and durability of 6-story hotel. So that's all from us. Thank you.